stand outside tonight and look up. Not at your phone, not at the street, up at the sky. Find a star, any star, and hold your gaze on it for a moment. That point of light left its source years ago, decades ago, some of them centuries ago, and has been traveling through the vacuum of space at 300,000 kilometers per second ever since, crossing distances so vast that the number of kilometers involved has more digits than you could speak aloud in a lifetime. And it has arrived at this specific moment at the precise location of your eye. You are the destination of a journey you did not know was happening. Now let us talk about how small you are. How small everything you have ever known is. How small the entire history of your species is. And why, by the end of this, that smallness might feel like the most extraordinary thing you have ever encountered. We will start with something familiar. The Earth has a circumference of just over 40,000 kilometers. That sounds large. It is large by any human standard. If you drove a car at highway speed without stopping, it would take you approximately 17 days to circle the planet once. The deepest point in the ocean, the Mariana Trench, descends 11 kilometers below the surface. The highest point, Everest, rises 8.8 kilometers above sea level. The total range of elevation on this planet, from the deepest ocean floor to the highest mountain peak, is less than 20 kilometers. The entire biosphere, every living thing that has ever existed, every ecosystem, every ocean, every rainforest, every creature that has swum or flown or walked or crawled on this planet is contained within a layer so thin relative to the size of the Earth that if you scaled the planet down to the size of a basketball, the biosphere would be thinner than a sheet of paper wrapped around it. Everything you have ever known exists in a layer thinner than paper on a basketball. The Moon is 384,000 kilometers away. That sounds far. It is 30 times the diameter of the Earth. If you drove to the Moon at highway speed, it would take approximately 5 months. And yet in astronomical terms, the Moon is so close to us that it is essentially touching us. On a scale model where the Earth is the size of a basketball, the Moon would be a tennis ball about 7.5 meters away. The gap between them on that scale is something you could cross in a few seconds of walking. Now let us talk about the Sun. The Sun is 150 million kilometers from Earth. That is 8 light minutes, meaning the light you see from the Sun left its surface 8 minutes ago. If the Earth were a basketball in that scale model, the Sun would be a sphere about 2.5 meters in diameter, and it would be sitting approximately 270 meters away. Not kilometers, meters. 270 meters is roughly the length of 2.5 football fields. You could walk it in 3 minutes. The Earth and Moon together would be invisible specks at one end of that walk, and the Sun, a glowing sphere the height of a person, at the other end. But here is where the scale starts to become something your brain genuinely cannot process. The Sun contains 99.86% of all the mass in the solar system. Everything else, every planet, every moon, every asteroid, every comet, every particle of dust in the asteroid belt and the Kuiper belt and the Oort cloud is the remaining 0.14%. The solar system is not a collection of objects orbiting a star. It is a star with some debris around it. And the Earth, the basketball in our model, is a tiny speck of that debris. The solar system itself extends far beyond the planets. The Oort cloud, the vast spherical shell of icy objects that represents the outermost boundary of the Sun's gravitational influence, extends roughly 2 light-years from the Sun in every direction. 2 light-years is approximately 19 trillion kilometers. On our basketball scale model, the edge of the Oort cloud would be roughly 55,000 kilometers away from where we place the basketball. The Earth is not at the center of the solar system. It is not even close to the edge. It is a speck of debris orbiting a star whose sphere of gravitational influence extends so far that even describing the distance in kilometers produces a number too large to visualize. Now, we need to leave the solar system entirely. The nearest star to the Sun is Proxima Centauri, at approximately 4.2 light-years away. 4.2 light-years is roughly 40 trillion kilometers. On our basketball scale model, Proxima Centauri would be over 100,000 kilometers away from our basketball. The scale has become completely untethered from anything human. The gap between our solar system and the nearest other solar system is not a distance you can visualize. It is a distance you can only describe, and even the description fails to produce any genuine emotional understanding of the emptiness involved. Between stars, there is essentially nothing. Not thin air, not a slight vacuum, nothing. The interstellar medium contains, on average, about 1 atom per cubic centimeter. A cubic centimeter of air at sea level on Earth contains approximately 27 billion atoms. The space between stars is not empty in the romantic poetic sense of empty. It is empty in the devastating physical sense. An almost perfect vacuum stretching for trillions of kilometers in every direction. Our galaxy, the Milky Way, contains somewhere between 100 billion and 400 billion stars. The range of that estimate tells you something important about the scale we are dealing with. We cannot count the stars in our own galaxy precisely. The galaxy is approximately 100,000 light-years across. If the entire solar system, including the Oort cloud extending 2 light-years in every direction, were shrunk to the size of a single grain of sand, the Milky Way at that scale would be approximately 8 kilometers wide. 1 grain of sand in an 8-kilometer wide structure. That grain of sand is our entire solar system. The Earth is a microscopic speck within that grain. We are not at the center of the Milky Way. We sit in one of the outer spiral arms, roughly 27,000 light-years from the galactic core, orbiting the center of the galaxy at approximately 828,000 kilometers per hour. At that speed, you would travel from Earth to the Moon in under 30 minutes. And yet at that speed, it takes our solar system approximately 230 million years to complete one orbit of the galactic center. In the entire history of life on Earth, our solar system has completed roughly 20 galactic orbits, 20 years in galactic time. We are not even old by galactic standards. At the center of the Milky Way sits a supermassive black hole called Sagittarius. It has a mass of approximately 4 million times the mass of our Sun. Its event horizon, the point beyond which nothing, not even light, can escape, is roughly 24 million kilometers across, while the entire orbit of Mercury around the Sun is wider than the event horizon of the black hole at the center of our galaxy. And Sagittarius, a star, is not even a particularly large supermassive black hole. Some galaxies harbor black holes billions of times more massive than our Sun. The black hole at the center of the galaxy, M87, has a mass of 6.5 billion solar masses. Its shadow was the first black hole ever directly photographed. The image that was released in 2019, showing that shadow, was one of the most significant photographs in the history of science, and what it showed was an object so massive that our Sun, which contains 99.86% of all the mass in our solar system, would be completely invisible at that scale. The Milky Way is not alone. Our galaxy is part of a group of galaxies called the Local Group, which contains approximately 50 galaxies, including the Milky Way and the Andromeda Galaxy, our nearest large galactic neighbor. The Local Group spans roughly 10 million light-years. The Andromeda Galaxy, which you can see with the naked eye on a clear night as a faint smudge of light, contains approximately 1 trillion stars, roughly twice as many as the Milky Way. It is currently approaching us at approximately 110 kilometers per second, and in approximately 4.5 billion years, it will collide with the Milky Way in a galactic merger that will play out across hundreds of millions of years, the two galaxies interpenetrating and eventually coalescing into a single elliptical galaxy. The stars within both galaxies are so far apart relative to their sizes that the collision will produce almost no actual stellar impacts. Two galaxies containing hundreds of billions of stars each will pass through each other and merge over hundreds of millions of years, and the stars themselves will mostly never touch. The local group is itself part of a larger structure called the Virgo supercluster, which contains over 100 galaxy groups and clusters spanning approximately 110 million light-years. And the Virgo supercluster is part of an even larger structure called Laniakea, a supercluster of superclusters spanning approximately 520 million light-years and containing the mass of approximately 100 million billion suns. Laniakea was only mapped and named in 2014. We have known the rough shape of our cosmic neighborhood for less than 15 years. And Laniakea is a small part of the observable universe. The observable universe extends approximately 46 billion light-years in every direction from Earth. Not 13.8 billion, which is the age of the universe in years. 46 billion, because the universe has been expanding during the entire time the light has been traveling toward us. So the objects whose light is just now reaching us have moved much further away since that light departed. The observable universe contains an estimated 2 trillion galaxies. 2 trillion. Each one containing hundreds of billions of stars. Each star potentially hosting planetary systems. And the number of planets in the observable universe is a number so large that writing it out in standard notation would fill more pages than have ever been printed in the history of human publishing. Now here is the detail that makes all of this stranger. The observable universe, the 46 billion light-year sphere of space whose light has had time to reach us, is not the whole universe. It is simply the part of the universe we can see. The actual universe is almost certainly much larger. Some models suggest it could be genuinely infinite. Others suggest it is finite but unimaginably vast, perhaps millions or billions of times larger than the observable portion. We genuinely do not know. The edge of the observable universe is not a wall or a boundary. It is simply the distance light has had time to travel since the Big Bang. Beyond it, the universe continues, and we have no way of knowing what is there or how far it goes, because the light from those regions has not reached us yet and may never reach us, because the expansion of the universe is accelerating. The universe is getting bigger, faster than light can cross it, which means the observable universe is actually shrinking over time, not growing. As the expansion accelerates, the most distant galaxies we can currently see are receding from us faster than light, and their light will eventually never reach us. The observable universe is contracting around us not in physical space, but in terms of what is accessible to observation. The universe we can see is a temporary window that is slowly closing. Sit with that for a moment. The Earth is a sphere of rock 13,000 kilometers across, orbiting an average star in the outer arm of one of 2 trillion galaxies in the observable portion of a universe whose true size is unknown and possibly infinite. Every mountain range, every ocean, every city, every war, every work of art, every person who has ever lived, every species that has ever existed, every thought that has ever been thought, the entire recorded history of everything we know has occurred on a speck of rock that from the outer edge of our own solar system would be invisible to the naked eye. In 1990, The Voyager 1 spacecraft, having completed its primary mission and traveling beyond the outer planets, was turned around at the request of Carl Sagan to take one final photograph of Earth from a distance of approximately 6 billion kilometers. In that photograph, Earth appears as a point of light, less than a pixel in size, a pale blue dot suspended in a shaft of scattered sunlight, a mote of dust in a sunbeam. The photograph shows nothing of what is on that dot. No continents, no oceans, no evidence of life, no indication that anything of significance has ever occurred there. Just a point of light, smaller than a full stop on a printed page, surrounded by the vast darkness of space. That dot is every love story, every battle, every birth, every death, every civilization that rose and fell before we had the tools to record it. Every piece of music ever composed, and every painting ever made, and every word ever spoken, and every dream ever dreamed. All of it on that dot. And Voyager 1 took that photograph from within our own solar system. It had not even left our neighborhood. I mean, from the nearest star, Earth would be completely invisible. From the center of our galaxy, it does not exist as a detectable object. From the Andromeda Galaxy, it is less than nothing. From the edge of the observable universe, the entire Milky Way is a single faint point of ancient light. We have been trying to find a framework adequate to this scale for as long as we have understood it, and we have not found one. The human brain evolved to navigate a world of meters and kilometers, to track objects moving at human speeds across distances a human can cross in a day. It did not evolve to feel the distance of a light year, let alone 46 billion of them. Every analogy breaks, every scale model fails, every number becomes meaningless at sufficient magnitude, and yet we keep looking. We keep building telescopes that can photograph galaxies 13 billion light-years away. We keep sending spacecraft beyond the edge of the planetary system. We keep doing the mathematics that extends our understanding past the boundary of what we can see. We are specks of organized matter on a pale blue dot who have looked up at the scale of the universe and instead of being silenced by it, have tried to understand it. Which raises the question that this video cannot answer, that no video can answer, that you will need to sit with yourself to decide what you think. Does the scale make us more significant or less? Does the fact that consciousness exists anywhere in this universe, that something as improbable as a mind, capable of asking the question, has assembled itself from atoms in a tiny corner of one of 2 trillion galaxies, make the universe more extraordinary or make us more negligible? Is it more humbling to be small in a vast universe, or more remarkable to be small and still be here, still looking up, still asking? The star you found tonight when you stepped outside, that light has been traveling for years to reach you. The universe sent it. You caught it. Maybe that is enough to think about for now. Good night.